Good day, welcome back to our channel. I'm Maile Matsiba. We're continuing today with our 2017 study guide of our CIR 113. We're starting today with section 2 of the study guide, which deals with mass balance. We're looking at example 5.1.1. It says the solubility of sodium chloride in water at 100 degrees Celsius is 28.5%. and at 0 degrees Celsius it's 26.3%. The question is, what is the percentage yield of sodium chloride crystals if the saturated solution at 100 degrees Celsius is cooled to 0 degrees Celsius? And there's a diagram there. Now, if one is going to be able to answer this question, we need to first analyze the diagram. We know that we have sodium chloride solution that is saturated at 100 degrees. It enters its one stream. But here we have two sodium chloride solution. That means the sodium chloride has split. There's the one that's left here in the mother liquor, and there's also the one that has formed crystals. So that is another important thing we need to understand. And another important thing, which is always something very common when you solve problems of this nature, or just when you deal with the mass balance, is that you always want the tie compound. A tie compound is usually a compound that enters with one stream, enters the system in one stream, and enter in the next stream without reacting. And we can actually analyze the water. We'll realize that here all the water comes in here, and all the water comes out here. So all the water comes in here, and all the water comes out here. And here in the crystals, there's no water. So that is actually what is it. So the water is a tie compound, which means if we were to get the mass of water here, that would actually be the mass of water there. So that is a very important principle that we need to have in mind. Now, moving further, we go into our second thing. What we need is we're going to choose a basis, and having three streams here, we need to choose a basis in like the easiest of bases. So an easy way of choosing a basis is actually to choose a basis of the solution. So we can just say our basis, we can just choose 100 kilogram of NaCl saturated solution at 100 degrees Celsius. At 100 degrees Celsius, this is actually the solution. So it's 100 kilograms. So yeah, can I just write here at 100 kilograms? So that's actually our basis. And if this is 100 kilograms, and remember that we actually have our mass analysis at 100 degrees Celsius. So we are told that the sodium chloride is actually 28.5%. So which means we can use the basis and the mass analysis to actually calculate the amount of both water and sodium chloride in the original solution. With that said, we can say NaCl equals to 28.5% over 100% multiplied by the total, which is 100 kilograms. It's important that you remember that just where we passed earlier in the first section, this is actually the mass fraction. When you take the percentage and the total percentage, and before you even multiply that, when you take the percentage and the total percentage, this gives you the mass fraction. So with that said, we get 0.285. The percentage is full of multiplied by 100 kilograms. So the mass fraction of NaCl is actually 0.285, and we got it using the percentage. So now this gives us 28.5 kilogram NaCl, which means at 100 degrees Celsius, this stream here has 28.5 kilograms sodium chloride when we use a basis of 100 kilograms. And therefore, the water, we do the same. We know if it's only water and sodium chloride. If sodium chloride is actually 28.5, then water is actually 100% minus 28.5, which gives us a 71.5% all over 100%. Now this is the mass fraction of the water multiplied by 100 kilograms, the total solution. So it gives us 0.175 multiplied by 100 kilograms is equals to 71.5 kilograms. Now with this said, we know that in this stream here we have 28.5 kilograms sodium chloride and 71.5 kilograms water. So now we go to in this stream here at 0 degrees Celsius. So after the cooling, now at 0 degrees Celsius, we've already said that we have a Thai compound, which is water. All the water comes in here and it comes out there, and we know the water is actually 71.5 kilograms here. Therefore, here at 0 degrees Celsius, water equals to 71.5 kilograms. So that is actually our water. And now, how much is the sodium chloride? We don't know. How much? Why? Because the sodium chloride actually split. However, one thing we have is that at 0 degrees, we also have the mass analysis. We know that the sodium chloride is 26.3%. So what we can do is that we can actually choose this stream, the mass, the total mass of the solution here to be X. Why are we choosing this to be X? We don't know the total solution, but we have the mass analysis. So we can just say, it's gonna be easy if we choose it as X. We can just say, let me just write it down. Let X be the total mass of NaCl saturated solution at 0 degrees Celsius. So at 0 degrees Celsius, the total solution is X. Now, if the total solution is X, remember that we have the mass analysis. We know that of this solution here, 26.3% is sodium chloride. Therefore, we can just use the same methodology we used here to calculate the mass of both sodium chloride and water in terms of X. We can just start, let's start with water. You can say water equals to, when we get here, we know that if sodium chloride is 26.3, water is actually 100 minus 26.3, which is 73.6. So it becomes 73.6% all over 100% multiplied by the total amount here is actually X. Right? Let me just get a blank page so we can continue that. Now, with that said, we can just say, therefore, remember we know the water. We know the water, how much the water is here. We already know the water that is actually 71.5 kilograms. So we can just continue to say 71.5 kilograms equals to 0.736x. Remember here, what's going to happen is the percentages are going to fall off. So 73.6 divided by 100 is actually 0.736x. Therefore, we can actually solve for x. We can say x equals to 71.5 kilograms all over 0.736. Therefore, x, then our x becomes, let me just confirm, then our x gives us 97.01493 kilograms. So with that said, we now know that our x, or rather, we're able to figure out or solve that the x, the amount of the solution here is actually 97. We calculate to be 97.01493 kilograms. So it was 100, now it's actually 97.13 kilograms. So with that said, when we have the amount here, we can actually go further to calculate. We can do a mass balance of either the salt or the whole system, but I just want to use the salt, though it's a little bit longer, but there's something I like about it. I just wanted to also along that highlight other things. So with that said, we know that if this is actually x, if x is actually 97.043, and remember that we know that the mass analysis of the salt is actually 26.3, so we can go further to say NaCl equals to, remember we still at 0 degrees, right? NaCl equals to 26.3% all over 100% multiplied by the x we know now. It's 97.01493 kilograms, and that gives us 25.515 kilograms. So that becomes NaCl. So with that said, the NaCl here is actually 25.515. But remember, we know that the NaCl that came in here is 28.5 kilograms, which means if we're going to make NaCl balance, you can say NaCl at 100 degrees Celsius, right? So let me write saturated equals to NaCl at 0 degrees Celsius saturated, right? Is 0 degrees Celsius saturated plus NaCl crystals. I hope my handwriting is crystals. Yeah, which means the total NaCl here equals to this NaCl here and that one. With that said, it means the NaCl crystals equals to, let me just confirm, the NaCl crystals when you is equals to 28.5 kilograms minus 25.515 kilograms and equals to 2.99 kilograms. So yeah, that's what it is. Now we have calculated, we know the amount of sodium chloride that form crystals, and we also know the amount of sodium chloride that actually entered here, the total. So the percentage yield is equals to NaCl crystals all over total NaCl multiplied by 100%, which gives us, we know this one is 2.99 kilograms, and we know the total is 28.5 kilograms multiplied by 100%, and that gives us 10.5% or 10.49. So that's what it is. And it's also important that I highlight that when we calculate percentage yield, we look at the total NaCl. There's NaCl here at 0 degrees, but it's not the total. The total is the one that entered here. So the percentage yield is the produced sodium chloride crystals all over the total sodium chloride that entered the system. So with that said, this concludes example 5.1.1, and yeah, thank you for this time, and I hope we meet again in our next video.